everyone. Okay, so I think we're live now. Hi, everyone. Welcome to another Tech Talk. We're thrilled today to have a presentation on how to develop your first cloud-native application with Nicholas here. I'll let him introduce himself a little bit more and a little bit better. But because we're already a couple of minutes late, we had a few technical glitches on our end. I will jump right into going to Nicholas and giving him a chance to give us some instructions and do his presentation. Thanks again, Nicholas, for doing this, and over to you.
Cool. Thanks a lot, Tanya, for the nice introduction. Let me share my screen. Okay, so can you see my screen in full screen mode?
Absolutely.
Okay, very good. So, yeah, hi everyone, and thanks for joining today. My name is Niklas Seidloff. I'm a developer advocate, and I work at IBM. And the topic for today's talk is how to develop your first cloud-native applications with Java EE, Eclipse MicroProfile, Kubernetes, and Istio. Okay, so I'm going to describe what these different technologies do, and more importantly, how you can use them together. Because sometimes that's a little bit confusing, especially when it comes to the positioning from Istio versus Eclipse MicroProfile. Now, earlier this year, I was looking for an application for a sample that would show you how to do all of these things together. Unfortunately, I couldn't really find the one application, the one sample. There are lots of samples for Kubernetes. There are really good guides for OpenLiberty, including MicroProfile. I just couldn't find the one application that would show me how to implement a full end-to-end application or an enterprise application, including authentication and front ends and persistence and all of this. So what I did was to basically develop such an application myself together with a colleague of mine who cannot make it today. And you can find the link here on most of the slides in the lower right corner. It's a link to a repo on GitHub in our IBM organization. And that repo is what I'm going to use here throughout this session for all of my demos. So after this, every one of you should be able to run all of the demos yourselves on your local machines. So I assume that actually all of you have heard about microservices and cloud native. So I don't really want to do here a long introduction. Just very quickly, this is the definition of microservices from Wikipedia, and I think it's pretty good. It says microservices are a software development technique that structures an application as a collection of loosely coupled services. And what that means is that you break down complex applications into simpler and smaller microservices. And that technique is really the core for cloud native. Now, when I started to learn about cloud native, I was under the impression that you would only need cloud native to build, let's say, the next generation of Netflix or any other really sophisticated application. But as it turned out, and what I learned is that cloud native is also very useful for other simpler applications. For example, there's this benefit of being able to implement applications that stay responsive, even when single microservices are not available. And similarly, you can continuously deliver new functionality, because the nice thing about microservices is that you can update them independently from each other. So for us as developers, there are new options, new possibilities. And that means we need to understand them. We need to understand the advantages and disadvantages so that we can decide which option we want to choose. Or as illustrated here on the slide, when there are multiple doors, you need to decide which one you want to open. And also new options often lead to new challenges. And here's an example. When you break down an application in multiple microservices, what do you do if a service A wants to invoke a service B in a distributed environment, but the network is not available? So you need to think about these new challenges. So real quickly, let me introduce the key technologies here: Kubernetes, Istio, and MicroProfile. First of all, Kubernetes. Kubernetes is an orchestration framework, and not only one of many, it's the de facto orchestration frameworks to run container workloads. It's open source project and it's well established. Basically, every cloud provider supports Kubernetes. So the nice thing is you can implement applications once and deploy them basically everywhere, whether that's a private cloud, a public cloud, or different cloud providers. And that's a really nice thing. In other words, there is no vendor login. Okay, the next technology here that we're going to use in the demo is Istio. Istio is a service mesh, and it's essentially an extension to Kubernetes that helps you to really manage microservices. The best example that I always mention is traffic management. So obviously with Kubernetes, you can do things like rolling updates, but Istio goes far beyond that. For example, if you want to do things like dark launches of new features, A/B testing, canary rollouts, all of this is well supported by Istio, and I'm going to demonstrate that a little later. And by the way, what you can see here in this little diagram is that the trick that is used here is to use these proxies. So the proxies are containers that run in the same pods together with the containers with your microservices code. Okay, and all the communication goes through the proxies, and that's why Istio can manage the traffic that well by using policies. Then obviously MicroProfile. MicroProfile is an open source project. It's a set of libraries and APIs that you as a Java developer can use to build microservices. Again, it's an open source project. The companies that are behind it are pretty much the same ones that are behind Java EE or now Jakarta EE. And the reason why MicroProfile is a separate project from Jakarta EE at this point is because the goal is to innovate really fast. And at least in the past with Java EE, that hasn't always been possible. Okay, and so far this really works well. There are many new releases. So back to my diagram here, this little puzzle, when to use what. Again, the question is, should you use Kubernetes and Istio, which are what I call generic platforms? And when should you use frameworks like Eclipse MicroProfile for certain languages, in this case, Java? Okay, and here is what I think should be done, or this is my suggestion, right? I say leverage the platforms Kubernetes and Istio as much as possible. So whenever you can do something with Kubernetes and Istio to implement and deploy microservices, use that functionality. Why? Because it's generic. It works for all types of microservices, no matter how they have been implemented. For certain microservices functionality, however, that doesn't work. Because at some point you need to write business logic, you need to write some code to do certain things. And I will give you several examples just as a heads up. Authorization access, like, think about a project management application which has a task and an owner of that task. And really only the application knows in that context who the role or who has this role owner of that particular task. Okay, so it's an example for something a platform like Kubernetes cannot deliver. And again, that's exactly where you would use frameworks like MicroProfile. So as I said, when I was looking for such an example that shows how to use all of these things together, I couldn't really find one, which is why I built my own. Okay, and before I show you the example, I had a couple of design goals that I want to quickly share. First of all, I'm a big fan of open source, and that's why I decided that all major components should be based on open source software, right? Which means that every one of you should be able to run exactly this application here yourself without having to pay any licenses or whatever. My next design principle was that I wanted to make the first time experience as easy as possible. And I think self-service doesn't end with a service available in the cloud. I think it's the same thing for samples. And I think it's rather simple to install the sample now. Please let me know if that's not the case. But I've tried, and many people have tried it now. And even if you haven't set up Minikube even locally or don't have a cluster, you should be able to install everything that you're going to see today in certainly less than an hour, because there's many scripts and documentation. And also the third design principle here was to be able to run on different environments. Okay, so there's documentation for how to run everything locally using Minikube. There's documentation how to use and scripts, how to run everything on the IBM Cloud, the IBM Cloud Kubernetes service. And then also just this week or last week, we added documentation for how to use OpenShift And we have two flavors. One is the open source version Minishift to run it locally. And the other one is a managed OpenShift offering in the IBM cloud, but the same instructions would work for any other OpenShift deployments. Okay, and again, that's the nice thing about Kubernetes, the ability to be able to run everywhere. So here's the architecture, and don't worry, I won't go through all of this now. I just wanted to show you the full picture. What I will do in the next minutes here is to really walk you through the single services. But as I said, I really wanted to provide here a complete end-to-end example, which means I wanted to have a modern front end, in this case, Vue.js. I wanted to have multiple microservices and obviously, some persistence and observability and all these kinds of things. And also, very importantly, authentication and authorization, because that's what you really need when you want to implement enterprise applications and not only simple public websites. So, but again, more about that example later. Now, let's get a little bit more concrete here. The first thing you need in order to develop microservices are container images and containers. Okay, and here's the definition of an image from docker.com. An image is a package of software that includes everything needed to run an application. And at runtime, you execute containers that work in their isolated environments so that they don't interfere with each other. The key benefit of containers is that they are portable. Everything you need to run an application, or in this context, actually a microservice, you put together in one box. Okay, the application server, the operating system, your actual application, and all of the dependencies. And I think it's a brilliant concept because, again, it allows you to run this code in different environments. And here's how easy it is to get started. This is all you need to define your first Docker image. This is the Docker file here in the right column. All you need are 3 lines of code. But before we talk about that, let me describe what's in that stack. As I said, I'm a big fan of open source. And I chose here a stack that is fully based on open source components. Okay, so starting with the OpenJ9. OpenJ9 is IBM's JVM, which we open sourced, I think, 2 years ago. And it's used in many of our offerings. In other words, it's enterprise proven. The nice thing about OpenJ9 is that it's really great to run container workloads. The memory usage is less than 60% compared to Hotspot, and the startup time is 40% faster than Hotspot. And the reason for that is that it was originally designed to run on really small devices. So that's component number 1 in the stack. Component number 2 is OpenJDK, and I'm using here a JDK release from Adopt OpenJDK. The nice thing about it is that, first of all, you get it for free, but you even get security updates for a particular JDK after 6 months of the initial release. And then the next component here is OpenLiberty. OpenLiberty is basically the open source version of WebSphere Liberty. And the nice thing about it is that it comes with MicroProfile, which I'm going to use here for several features. So here, again, in the Docker file, that's all you need to do, 3 lines of code. This first image that I extend here, OpenLiberty, that's the one that contains the complete stack that I just described. So all I need to do is to say here from OpenLiberty, and I'm done. And the other 2 files I need to copy onto the image are server XML, that's just a little server configuration, and then the WAR file, which contains the implementation of the actual microservice. So that's step number 1. And this is, by the way, the front end of the sample application. It's very easy, okay? It's just a website that lists 5 or 10 different links to articles together with information about the authors, the links to the Twitter profiles and the blogs. It's very simple, and to be honest, for such a simple application, you probably don't need a cloud native approach here and all this complexity, okay? But we wanted to keep the example really simple so that you could easier understand the different features, okay? So again, the UI is not really that impressive, but what's going on, I think, is pretty interesting, and that's what I'm going to describe now. So after you have defined the image, the next thing you need to think about is how do you communicate between the different microservices? Okay, because as I said, microservices means, or cloud native means, you break down complex applications in multiple microservices, and then you need to think about how do they communicate. And there are many different alternatives here, many different protocols. You can do it synchronously, asynchronously. This example shows a very easy, probably the easiest approach, and maybe the most typical one to get started, which is to use REST API and synchronous invocations. Okay, and this goes in two directions here. So let me talk about the different components. The left column, this is the browser running a web application implemented with Vue.js, but it doesn't really matter in this context. And that one invokes APIs from the web API service, the blue one here. Now, this one implements a backend for front-end pattern, which means the web front-end only invokes API or APIs of that single service. But the web API internally invokes then two other microservices, articles and authors. Okay, so what that means is you need to expose REST APIs to the outside. For example, the web API service needs to expose the APIs to the web app. And vice versa, the web API also needs to be able to invoke REST APIs from articles and authors. And here's how it's done. So this is the example, this is the implementation of the method getArticles, the API that returns the list of articles, okay, the endpoint getMultiple. And in order to do that, you can use standard JAX-RS. So this is nothing new, right? So that's why I'm go through it here really quickly. All you need to do here is to use the known annotations like get, path, producers, and so forth. Additionally, you can use here OpenAPI or Swagger to do further annotations so that you can document the interface of your endpoint directly in the code to make sure the documentation doesn't get out of sync with the actual implementation of your API. And again, very simple and straightforward. You have here these annotations like API responses and operation and so forth. Once you have done that, you get a nice UI, a nice web front end that is delivered with OpenAPI and integrated in OpenLiberty. And this is basically the documentation of the API. But not only that, it's also an API explorer. So what you can see here is that you can actually execute these APIs directly from this web UI. So it's basically a test UI if you want. So nothing really fancy, but I think very nice, very easy to use when you use Java EE and MicroProfile. And then the next thing is you want to be able to invoke other services. Again, the web API service, in this case, wants to invoke the author service. So, and this is now the first time where MicroProfile comes in, because MicroProfile provides this really nice REST API, and it allows you to invoke other services very easily. Okay, and this is what you see here. This highlighted snippet shows that you can define an interface to the author service. And that's really all you need to do. Just an interface here, the public method getAuthor. And you don't have to worry about the implementation, because the implementation is provided for you more or less magically by MicroProfile, by the REST client. Okay, all you need to do here is to define the DNS name and the path of your endpoint, right? This is the first highlighted snippet. And by the way, Kubernetes takes care about the service discovery, right? All you need to know is the DNS name, the name of your service, and all the routing and magic that goes on there. That is something that is handled by Kubernetes for you. Okay, very easy to use from a developer point of view. And then the second snippet here shows how you can now invoke the service. And the nice thing here is, again, you don't have to implement this interface, right? You get the implementation magically, and you even get a typed interface. Okay, so very easy to use, and you don't have to worry about all the marshalling, unmarshalling of data. So that was scenario number one, if you want. Now, the next scenario is traffic management, and that's where Istio comes into play. Now, I have another little demo here, and in order to show how to route traffic, I created a second version of the web API service. Okay, and the second one is very similar to the first one. This is the first one, which returns 5 different articles. Okay, and the second one returns 10. So in other words, when you deploy both version 1 and 2 at the same time, and you hit refresh in your browser, you will see sometimes 5, sometimes 10 being returned. Okay. Now, Istio allows you to control this traffic and to define what exactly or how exactly you want to expose these different versions. And here's how it's done. As always, typically you use YAML files, okay? And then Istio has some additional resources. In this case here, it's this resource called virtual service that you put on top of the service that is provided by Kubernetes. And once you do that, you can then go ahead and define these routes here. You can say, okay, version 1, I want 80% of my traffic to be routed to, and version 2, 20%. It's a very simple sample, but again, you can do much more. You can route, for example, based on the headers in the request. You can say, okay, all the users who come in from a mobile device should get, this version, and the other ones should get another version. You can even use your regular expressions and what have you to say only these types of users, are allowed to see. So again, you can implement or do things like A/B testing and dark launches. And I think it's really important if you implement more sophisticated applications that you don't want to roll out directly to 100% of your users, but you really want to do some testing in your production environments first and want to get some user feedback first before you roll it out to the bigger masses of users. And again, very easy to do. Now, once you have deployed or applied this policy, you can actually see that the routing works. And this is a tool called Kiali. Again, obviously also open source, which is now part of Istio. So once you install Istio in your Kubernetes cluster, you get this tool for free. And I think it's really an awesome tool here because it shows you automatically all the, how the traffic flows. And what you see here again is the web API service with version 1 and 2, and also the articles and author service. It looks pretty similar to what to the architecture diagram that I draw manually, but this one hasn't been drawn here or anything, right? This is data that Kiali gets from Istio, and it generates, this diagram automatically based on the data on it. Okay, next cloud native scenario is resiliency. Okay, so resiliency means that your app remains responsive even when single microservices are not available. And in this case, I want to demonstrate it by shutting down the articles and the author service. And I want the web application still to be able to display the articles. And I want the web API service to still be responsible. Okay, so that's a little demo scenario here. And this can be done rather easily. And this is a case now where, as I said at the beginning, you cannot rely on the platforms. You cannot rely on Kubernetes and Istio. Why? Because this functionality is application specific. This is something that you need to implement in your code. And here's how it's done. Very easy. This is case number 1, which is what can you do when the author service is not available? So what you see here is the implementation of the endpoint get articles of the web API service. And the highlighted snippet shows what happens when the author service is not available. The solution here is very easy. Instead of not returning any articles, you simply return the articles, but without the author information. So this is plain old Java, nothing fancy, okay? But then to go one step further, and again, this is where MicroProfile comes into play. This is what you need to do or can do when the article service is not available. Because when the article service is not available, an exception is thrown, and that triggers another method, a fallback method. And you can define that by using this MicroProfile annotation at fallback. So in this case, we invoke the fallback method, and that one simply returns the articles that were read the last time the article service was available. So in other words, all we do here is to use a simple caching. Okay, nothing fancy and really easy to do. And here's how it looks in the UI. This is the UI, the sample application, fully functional when all services are available. As soon as you shut down the author service, you can still see the links to the articles, but without the links to the Twitter profiles and blogs. Okay, and even when you go one step further and when you shut down the article service, you would still be able to see the same list of articles. Okay, next scenario, authentication and authorization. And to be honest, this one was, for me anyway, the hardest part to get it to work because I really assumed that Istio or Kubernetes would provide more support in order to build these things. But let me give you some background first. Now, in order to do authentication authorization, I really want to go with standards here. And I think the standard way to do that these days is to use OpenID Connect, which is an extension of OAuth. In other words, it gives you an access token, but also an identity token, which means you can use it for both authentication and authorization. Okay, and for example, when you use it together with JWT tokens, the JSON Web Tokens, there is nice documentation in Istio that tells you how you can make sure that a user is authenticated when invoking certain endpoints. And that's exactly what you see here. So this is the simplest sample if you want. This is, again, another YAML where you can define a policy. And you define this policy here for the Web API service, and more specifically for another endpoint that is called create, and that allows you to create new articles. Okay, and all you need to do here is to say, okay, the user that invokes this method needs to have a valid JWT token from the OpenID provider, in this case, IBM AppID. Okay, very easy and straightforward. Now, as I said, it wasn't really, at least for me, not really as easy as I wanted. And I had expect to get some functionality from Kubernetes that would help me to get the JWT tokens, because there's documentation that tells you how to use a JWT token in Istio and MicroProfile. I couldn't really find good documentation that tells you how to get it in the first place, at least not from my specific OpenID Connect provider, using open source only. Okay, so what I ended up doing was I implemented this authentication service, and that does nothing else than connecting to an OpenID Connect provider to get the JWT token. And that OpenID Connect provider can be, Twitter, Facebook, what have you, or I chose here an IBM service called IBM AppID. Now, the reason why I chose it here is because when you want to build enterprise applications, you don't want to recreate your users in some cloud directory or whatever, but you want to be able to access and integrate your existing organization directories. And that's one of the nice things that IBM AppID allows you to do, because you can, connect to your Active Directory using XAML. You can, leverage your existing login dialogues and all of this, right? So that's why I chose it. But it's only an optional component. So just quickly here, everything that you see in the two left columns, this is all open source. Everything in the right column is not open source, but it's optional only, and it's relatively easy to replace with other implementations. Okay, so yeah, that's essentially what I did. I added this authentication service so that I can get the JWT token, and once I have the JWT token, I can pass it into the Web API invocations. And here's an example. So first of all, I want to be able to log in. This is the login page that AppID provides for you. It looks pretty blank and easy and straightforward, and that's the intention here. Obviously, you can customize it to your needs, right, for your own branding, company branding. And as soon as you use XAML, you would use your own login page anyway, and you wouldn't have to create this one. But for testing purposes, I just use this one here with just two test users, user and admin. So now I can log in. And this is the little UI to create a new article. You define a title, a URL, and an author. And then you can click on Submit. And as you can see here in the upper right corner, I'm logged in now as user. Okay, and since I'm logged in, I can now invoke this create endpoint that I protected using this Istio policy. And in here, in the lower right corner, the highlighted, not snippet, but the request headers show that I passed the access token as a bearer into my authorization header. And that's really all you need to do. Okay, so if I don't do that, if I try to invoke the same create method as an anonymous user, I would get an exception, which is expected. Okay, now to go one step further, once you have the JWT token, you can, define these policies in Istio YAML files, or you can even use it in your Java code, again, using MicroProfile functionality. And just quickly, here's how it's done. So in the server XML file, this is the configuration file of OpenLiberty. You define a couple of things about the JWT token. First of all, again, what is your provider? In this case here, it's IBM AppID. And then you also need to have a key store that contains the public key of app ID, right? Because what MicroProfile needs to do is to verify the tokens when the tokens get passed in. So it needs to know the callback, and it also needs to know the public key so that it can do the handshaking and so forth. And then in the Java code, you can finally use the JWT token very easily here just by using this dynamic injection. And this is the easiest possible way to use it. So all I do here is to check the email address. So when you get the JWT token, you can get all the claims, the different roles and everything, right? In this case, I make it really simple. I say, okay, if the email is the email of the admin is allowed to invoke this endpoint called managed, which doesn't do anything. It doesn't really make sense, but just for illustration purposes, right? And if you are an admin, you can do it. If you're not an admin, if you're just a normal user, you know this method would return an error. Okay, good. Next topic, observability. So this is something that developers now need to understand at least more than previously, right? So a couple of years ago, I remember, developers typically would just want to implement code and then throw it over the fence, and someone from ops would pick it up and operate and deploy and everything, right? This is not how it works anymore with cloud native and microservices. This is not how the whole DevOps culture really works or should work, right? You really want to bring together all the different people. You build and deploy and operate a full microservice, a full application end to end. And that means that developers at a minimum need to understand these different observability topics. For example, tracing, logging, monitoring, metrics, health checks, and so forth. So to give you some examples, let's make it more concrete again. And let's start with logging. Okay, because that's what every developer understands. You implement something doesn't work, you want to know where's my log file. Now in this case, there is not the one log file anymore, right? So the question is, where can you find all the logs in one central place? Unfortunately, there are ways and tools that allow you to do that. So again, here's a little sample. You know this now already, the web application invoking web API and web API invoking articles and authors. And if everything works, you can see now all the logs here nicely in one place. This is a service called LogDNA. It's available on the IBM cloud. It's not an IBM service, but it's a third-party service that is available in our catalog. And again, the nice thing here is that you can filter down to certain microservices, or what they call it here, apps. So you can say, okay, I want to only see my logs from articles, web API, and authors in one view. And this is exactly what you see here. Now, again, let's delete the author service. And in that case, the web API will throw some exceptions. And again, this is exactly what you see here. And it's just a very simple example for how you could figure out why something doesn't work the way it should work. Next topic, still part of observability, it's tracing. And what tracing means is, how can you see which service invokes which other service, how long does it take, are there bottlenecks, and so forth and so forth. And the way you do that is by using open tracing, which is a vendor-neutral API. And then there are different tracing systems like Jaeger and Zipkin. And you can very easily just use that in MicroProfile. All you need to do here is to include a separate open tracing Zipkin file, and you don't have to do anything else. In other words, you don't have to forward any HTTP headers or anything. All of that is done for you by MicroProfile. So you just write the Java code as always, but then you get additional tracing information. That tracing information is stored, and then you can use, for example, here the Jaeger UI to see what exactly is going on. In this case, what we see here is that the web API was invoked, and the web API service then invoked the article service. Okay. Next topic, metrics. And here's another example where MicroProfile comes in, right? Because certainly the platforms, Kubernetes and Istio, they can do a whole bunch of monitoring for you already. Like, for example, how many times was an endpoint invoked, right? But for other scenarios, that's not possible, because sometimes you want to track certain information that happens somewhere down in your Java code, which is not exposed as endpoint directly. And that, again, is where MicroProfile comes into play, because MicroProfile provides these additional annotations, for example, timed, counted, metered, and so forth. And that allows you really to see more to store more information in a Prometheus database, and then also to use the Prometheus UI to see, in this case, the number of invocations of a certain method. And I think this is the last topic about observability, health checks. Now, this is also important if you run container workloads on Kubernetes, because Kubernetes' responsibility is to make sure that certain applications or microservices stay up and that enough instances are up and running. And if not, new services are started. If there are too many instances, then they are shut down and so forth. And Kubernetes needs to be able when and if an application or a microservice is actually running. And the way this is done is by using here these two probes called liveness probe and readiness probe in the YAML file of the deployment of your microservice. Okay. Now, it's important to understand that there are actually two different probes. Liveness means when is the application server available? When has it started? But that's not always the same time when the full application is available, especially when you need to do a lot of initialization first. For example, if you want to create a database connection, it takes some time, right? So there's a delay between the liveness probe and the readiness probe, and that's why you have these two different ones here. Now, in order to define when an application is actually ready, you can use another MicroProfile function or functionality. It's here this health endpoint and the health check interface. And in this call method here, in the first snippet, you can simply define when the application is ready. Okay, so in this case, it always returns ready, which doesn't really make much sense, because in this case, the liveness probe would be the same as readiness probe, more or less, but you get the point. And in here, you could then add checks for, is the database connection there? Next topic, and that's the last bigger topic here, it's persistence, because that's another thing you typically need to build, complete end-to-end enterprise applications. And what I've done here is to use JPA for the persistence of the article service. And again, as you know, everything in the right column here is not an open source component. And I'm using here another service from the IBM cloud called DB2. But since this is just an SQL service or database, and since we are using JPA, obviously, as you know, this can be changed very easily. So it's really just an example. And here's how you do it. This is, again, some configuration that you need to do in the server XML, the configuration file of OpenLiberty. And just on a high level, you need to do at least two things here. One is you need to define the database driver, the JDBC driver. And the second thing is you need to define your credentials to access that data source. Okay, once you have done that, you can use standard JPA functionality. And in this case, the article service stores articles. So there's one table called article, which stores entities called article. And every column here is one property in the class. And the property ID here is this special column with the UNID. And here's how it's done, very easy and straightforward. And I think there were some other webinars about it previously. So if you want to find out more, check out those. So I said I use here SQL as the database for articles. However, it's only optional. By default, I'm using an in-memory store. Okay, and in order to switch between the in-memory store and the SQL database, I'm using here configuration. And as always, when you talk about 12-factor applications, you should make sure that the configuration is stored externally and not in your code. And this is exactly what I do here. So this YAML file contains here my config map and then my environment variables. For example, here, the variable whether or not I want to use an SQL in the SQL database or an in-memory data store. Okay, then in the Java code, it's very easy to use. You simply use, again, here the add inject and then add config property, dynamic property injection, and give it a name and a default value. And that's really all you need to do. Very easy and straightforward. So that brings me almost to the end. I think everyone who wants to learn more about microservices and cloud native, this repo should be a good starting place. Again, because we really focused here on first-time user experience. We wrote many scripts and documentation, and I saw the other day that we actually wrote more lines of code for scripts than actual Java code. And again, it should be a matter of 30 minutes, maybe an hour to set up everything locally. And if you have already a cluster, it's even much faster than that. So I, just recommend check out the sample if you want to know more about it. And I would love to get feedback, by the way. If you like the sample, let me know. If you don't like it, if there's something that doesn't work, let me know. I really want to maintain it, and I really want to use it at further conferences, talks, and so forth. So let me know if there's anything that doesn't work. So this is just a screenshot of the repo called Cloud Native Starter. And in there, there's also many links to blogs. I think we wrote a series of 25 blog entries about it. So if you want to find out more about the topics that I just talked about, go to the repo and check out those links. And obviously, I also want to call out here that IBM has a Kubernetes service, which I think is pretty good. Why? Because first of all, it's a managed service. It's very easy to get your own cluster just by clicking one button and basically choosing what server configuration you want to have. We support, there's many data centers worldwide. We have multi-availability zones. You can choose from many different hardware configurations down to bare metal. And I think we are the only ones supporting bare metal for managed Kubernetes. And the other nice thing is there is a managed Istio and a managed Knative plugin. So if you want to play with these technologies, just go to our cloud, get a free light account, and then play around with these things and try out this example, which, as you know, requires Kubernetes as well as Istio. And that brings me to the end. Here's a quick summary. This QR code is a link to the repo if you want to take a picture and go there. And just quickly, as I said, sometimes it can be a little bit confusing when to use what, when to use Kubernetes and Istio on the one hand side, when to use MicroProfile or other frameworks on the other hand side. Again, I think you should use as much Kubernetes and Istio functionality as possible because it's generic. But sometimes that's not sufficient. Sometimes you need to implement microservices functionality in your code, and that's exactly where MicroProfile comes into play. Second point, IBM loves open source. I love open source. All the core components of this example are available as open source. And I also told you that IBM has done a lot of good things for open source recently, a lot of great contributions like OpenG9, Adopt OpenJDK. We were part of OpenLiberty, and we are part of the Cloud Native Computing Foundation. Istio is basically the original idea of Istio came from IBM Research. So there's many things that we are doing around open source. IBM Developer is our portal, our entry page essentially for developers. There's lots of other good samples, tutorials, videos, and so forth. And if you want to get started, there's a free light account, which basically gives you access to many of our services. It's free. You don't have to give us a credit card. There's no time restriction, and you can just go ahead and play around with all of these nice things. If for nothing else, then just to learn new technologies and play around with these things. Okay, and that's everything that I had prepared. And I think we have, at least some minutes here for questions and answers. Is that right, Tanya?
Yes, that's correct. So everyone, please type in your questions. There is a question. I'm not sure exactly what, Bruce, what is your question with regards to Open Liberty, but I believe it may be related to if Open Liberty is implementing MicroProfile. So I'm sure Nicholas, or if it's something else, please let me know what is the question really about. But Nicholas, you can certainly comment on how great Open Liberty is and what it provides to people.
So I'm not sure I understood. So the question was whether MicroProfile is part of Open Liberty?
No, that's my guess, right? So there is just Open Liberty question mark. So Bruce, if you want to clarify exactly what you're referring to, but in the meanwhile, we can talk about maybe Open Liberty and their implementation of Jakarta or Java EE/Jakarta EE and MicroProfile.
Yeah. Open Liberty is our open source version of WebSphere Liberty. It's a lightweight Java EE application server, very flexible, and it comes with an implementation of MicroProfile, right? So it's updated regularly with the latest and greatest MicroProfile releases. And as I showed, there's also all these Docker images, so it's really easy to get started without really having to install, a big standalone or local installation. You just can use the Docker container and then go ahead and build microservices.
Yeah, thanks, Nicholas. Any more questions? There was another question from Federico, but I see that was retracted. So if there are any other comments or questions, please do let us know. Now is the time. Otherwise, just a reminder, have your eyes open and your social medias ready to monitor for the next Tech Talk. And oh, there is another. Istio is node balancer. I suppose Armita Raj is asking if the service mesh is equivalent to node balancer.
I'm not sure I understand the question. Can you say a little more? I mean, what I showed is here that Istio comes with its own ingress, right? And you can use that to then route traffic, to various other services. So that's really the entry point into Istio.
Okay. Anything else? And does that answer your question? Okay, so it seems that this is everything we have for today. Well, thank you so much. Do keep in mind that the recording will be available, and you can always get in touch with Nicholas or me over the web. So if you come up with the follow-up questions, we'll make sure those get answered. And thank you so much for attending live, and we'll be in touch.
Okay,
again,
thanks a lot.
Yeah, Nicholas, thank you so very much. Okay, bye everyone.
Thank you.